Thanks for watching this screencast. The objective of this screencast is learners will be able to graph a linear function by finding its intercepts. So for a linear function, here's the graph of a linear function. There are two important points that are called the intercepts of a linear function. Sometimes it's the same point twice. Sometimes a certain type of function only has one of these. But for most linear functions, they will have what we call both an x-intercept and a y-intercept. So the x-intercept of a linear function is the point on the graph where the line crosses the x-axis. So, for example, on this linear function here, this is the x-axis, the horizontal axis, and the point right here is the one that we call the x-intercept. Sometimes we abbreviate intercept like int. It's the point where the line crosses the x-axis. This is the ordered pair 2, 0. Now this linear function also has a y-intercept. The y-intercept of a linear function is the point on the graph where the line crosses the y-axis. This is also the point that we saw in the previous instruction, was the b in y equals mx plus b form. So this is what we call the y-intercept. And for this specific linear function, the y-intercept is the point 0, 3. And it's worth pointing out how you find these. The way to find the x-intercept is to let y equal 0. The y-intercept is the x value when y equals 0. And that's because y equals 0 is another way to say the x-axis. Similarly, if you want to find the x-intercept, if you want to find the y-intercept, we want to let x be 0. Because the y-intercept is another is the line where all the x values are 0. So let's work an example together. We're going to graph this linear function by finding the x and the y-intercepts. Now this is not in slope-intercept form. And to be honest, we'll show you another way you can solve this same problem in the next instruction, the next screencast as well. But to find this graph by finding the intercepts, I want to find the x-intercept. So I need to write out the work that will do that. To find the x-intercept, I'm going to write the equation of the line one more time. To find the x-intercept, I want to let y be 0. Think of like cover up the y. Cover up the y term, cross it out. Let y be 0. And what you get is 5x equals negative 15. And you can solve that for x. If you divide both sides of that equation by 5, you get x equals negative 3. So the x-intercept is over here at negative 3, and let's go ahead and plot that point. That's the point negative 3, 0. And I also would like to find the y-intercept. So I'll write the equation 5x minus 3y equals negative 15. But this time, I'll cover up the x. So cross out the x term and write exactly what's there. Don't lose this minus sign. That's negative 3y equals negative 15. And if I divide both sides of that equation by negative 3, well, I get y equals positive 5. Or I get the ordered pair 0, 5. 0 because I let x be 0. So 0, 5 is the y-intercept. Now, I've got 2 points that are on the graph. I could think about finding the slope between them. A slope of up 5 and right 3, 5/3. I don't really necessarily need to write that slope. What I need to do is to use that pattern to find other points on the line. So I could go up 5 and right 3, or in this case, I could go down 5 and left 3. And that would find me another point on the line. And here's the line now. All you really ever need to have an idea of what the linear function will look like is 2 points on the line. And there's a pretty good graph of that line. Let's look at another example. It says graph the linear function 2x plus y equals negative 4. So to find the x-intercept, I'm going to think about taking the equation 2x plus y equals negative 4. And to find the x-intercept, I'm going to cover up the y term, or cross out the y term. I'm going to let y be 0. And what I get is 2x equals negative 4. And if I solve that equation for x, I get x equals negative 2. Or, since I let y be 0, I get negative 2, comma 0. Which is the point right here. To find the y-intercept, I need to take this equation, 2x plus y equals negative 4. And to find the y-intercept, I need to cover up the x term, or cross out the x term. Now this example is kind of nice because all I get is y equals negative 4. There's nothing left to do to solve this for y. It's already there. If x is 0 and y is negative 4, I need the point 0, comma negative 4. And I'll plot that as well. And it looks like the graphing pattern here would be to go down 4 and right 2, which is actually the same as going down 2 and right 1. I could even put that point in there if I need to. So let's use that pattern, down 2, right 1. And there's a pretty good sketch of the graph here. Well, there's the graph right here. Emphasize again that this is a linear function. It continues forever in all directions, so I really want to have the arrows there on the end. Alright, you know what time it is. Hit pause, try this one on your own, and when you think you've got it sorted out, hit play to get some feedback. Alright, let's graph this by finding the intercepts. For the x-intercept, I need to use the equation negative 4x plus 3y equals 12. But to find the x-intercept, I need to cover up or cross out the y term. So what I really need to solve is negative 4x equals 12. And if I divide both sides by negative 4, how about x equals negative 3? And since I let since I let y be 0, that's the point negative 3, 0. Right here. To find the y-intercept, I need to take the equation negative 4x plus 3y equals 12. And to find the y-intercept, I need to let x be 0, cross out the x term. And what I need to solve is 3y equals 12. And if 3y equals 12, what does y have to equal? Yeah, it's 4. And since I'm letting x be 0, it's the point 0, comma 4. Let's plot that right here. Looks like the pattern for graphing is to go up 4 and right 3. Next one would be off the graph here, but I can always go down 4 and left 3. And the line's going to go through here. Something like that. How'd you do? Thanks for watching.
Goodbye, Algebra students.